Hey, we're gonna do multiplying polynomials. If you already checked out the Blackboard announcement, I already will have this posted there. It's how to do multiplying polynomials with using the rectangle method. I think this is the best method to use when you're multiplying any two polynomials. You might have heard FOIL, first adder, inner last, but that only works with a binomial times a binomial. Here we're going to be doing different sample questions that I have posted up here. So right now I have question 13. I have 5 of them that are going to be on the test that are be multiplying polynomials. So the first step, it says, for the rectangular method is to count the number of terms in each polynomial. So for example, this one has 1 term, monomial, and this one in the parentheses has 3 terms. This one's known as a trinomial. It does not have to deal with the exponents. Remember, terms are separated by subtraction and addition signs. So this is 3 terms, this is 1 term. After you count the number of terms in each polynomial, it says to do the rectangle method, we're going to draw a big rectangle. When you draw a rectangle, it's going to have columns and rows based on the number of terms that we have here and here. So for example, in this case, I'm going to draw a big rectangle. And I'm going to put in rows and columns. Now, it doesn't matter if you call this rows and this columns, or vice versa, and columns and rows. So for me, this is going to be rows, and this is going to be columns. You're going to divide this up into look like a rectangular grid. So if I say 1 row, that's good. 3 columns, there's column 1, column 2, column 3. The next step is you're going to place the polynomials on the outside edge. So we got the 8a to the 4th. You're going to put that on the outside. And then the 3a to the 5th minus 2a cubed plus 5, you're going to put that also on the outside. One is going to be placed on the left side, one's going to be placed on the top. So because this only has 1 space, you're going to put the monomial here. Because this has 3, we have 3 spaces here, you're going to squeeze that in right there. Make sure you include the signs. Once you do that, now we have to fill in the individual squares. To fill in the individual squares, remember, we're going to use the product rule. The product rule says that if you're multiplying like bases, you're going to add those exponents. So when I do this, a to the 4th was a to the 5th. Notice that there's 4 here plus 5 here. That means altogether we have 9 a's. Then you're going to multiply the coefficients or constants. So here we know this 3 is a coefficient. We know this 8 is a coefficient. Multiply and we get 24. Okay? The next one, you're going to multiply a cubed and a to the 4th. So you're going to have 3 plus 4, 7. And then multiply -2 times 8 is -16. And then here, notice that there's no a's here, but remember we're adding 4 plus 0 means that we have 4 of them. And then the constant times the coefficient, 5 times 8 is 40. The next thing that you want to do is to collect any like terms. So notice that we do not have any like terms here. Each one has a different exponent. Even though they all have a's, remember, it has to have the same variable part. That is the variable and the exponent. So since none of them match, just make sure you arrange your answer in descending order. So you're going to start with your highest degree, your highest exponent first. Minus 16a to the 7th, and then positive. Notice it was positive, so I have to put a plus sign here to separate these two terms. 40a to the 4th.